It does. This will be the driver. It's a BLDC motor. I think I've talked about this motor in my past video. Let's check my former uploads. Then this is an alternator. It's rated for 12 volts, maximum of 20 amps. It's from a tractor. So if I use it as an alternator, at the rated capacity, it's supposed to give 240 watts maximum, 12 volts, 20 amp. So the amp remain constant when it reaches its rated speed and torque. When it is driven at its rated torque, it will deliver 20 amps. So even if the torque exceed that and the speed exceed that, the amperage remain constant. What can change is the voltage. So voltage is directly proportional to the RPM at which you are driving it. So what does it mean? This means that if I drive this at a higher RPM, that I can get more voltage for the same amp. So I can get more than 240 watts. So if I multiply by 10, if I can multiply the speed at which I get it at 240 watts by 10, that means I can get 2400 watts with this small thing. Let's go to work. But I've opened it so that you see the inside. You already see how this driver looks like. It's a 38 volts. It's a 38 volts driver. Let me see, bring the light closer. 38 volts, can you see it? That's it. That's the input there. 38 volts. So I'm going to first of all use 12 volts to drive it. I'm going to remove the board and connect the phases in delta form so that it will get more strength. So let's go to work. So this is how the inside looks like. There are 8 magnets there. And there are 8 starter coil. You see them? The same thing you have in a motorcycle alternator. That's the same thing. This is rated for 20 amps maximum. So I put them together already. As you can see, that's the generator, the alternator there, and that's the driver. I put them together. I want to drive it with a 12 volt battery. I'm using this controller. It's only 12 volt controller. I cannot go far. The farther I can go is 20 volts. So I may use a laptop charger to also check it. Let me see the raw output AC raw. So now I have a rectifier, an inductor, and a capacitor there. I will later connect it to it and see how far is generated voltage. Now let's connect it. So it's on, it's working. It's giving 13.8 volts. At 12 volts, it's giving 13.8 volts. So the next step now is to rectify it and see if it can carry load. So Maybe I should put the load like this directly. Yes, let me put the load like this directly and take off. I think for now. So I'm going to test run this load. I have a 3 incandescent car headlamp that is 180 watts. So it's supposed to be producing 240 watts as rated. So 180 watts is okay for the test. So let me on it. And it does. And it does. We carry all of them 180 watts. So in my next video, it does. It does. So now I connect the laptop charger. The laptop charger is 19 volts. 19 volts is giving me 23 volts plus. 23 volts plus, as you can see, 23.2 volts. You see? Performing excellently. So from 12 volt battery to 19 volts, and now from 13.8 volts output to 23 volts. I'm going to use my e-bike battery, 36 volts. I'll connect it, so that's the maximum rating of this driver. Then let me see the output. Now, at 20 amp, you have 23 volts. 20 amp, 23 volts. So now you have more than 400 watts already. From 240 watts, you have more than 400 watts already. So in my next video, I'm going to increase the voltage and test the output. Thanks for watching.